Okay, so matter is classified into mixture and pure substance. So for today, we're going to focus on pure substances only. On this section here, pure substances are further classified into two. We have compounds and elements. And there is a guide question that will help us recognize or distinguish between these two. The question is, can it be chemically decomposed? Decompose, the other term for that is split up. Can it be split up? If the answer is no, it's an element, and if the answer is yes, it's a compound. So let's stop right there and let me show you a molecular model of an element and a compound, and I want you to make your observation. Let me put this away, and let me show you this and this one. Okay? So I hope that my molecular models are clear on your end. The one that is in red is considered an element, and the one that has a lot of colors is considered a compound. Now, based on your observation right here, this is an element and this is a compound. What is the difference, or a very obvious difference, between an element and a compound? Can somebody tell me an obvious difference between an element right here and a compound? Anybody who can tell me? Unmute?
Compound is bigger.
Okay, one at a time.
Element it's like made out of one specific compound, while the compound is like made of different type of things.
Very good. So you see that you have the same circles, same color of the circle, and the same size for an element. Same color, same size, that means the identity of your element is made up of one type of atom, because it's just one color, one size, so one identity. On the other hand, for a compound, you will see here that it has different sizes of circles, and at the same time they have different colors. They have different colors. So that means that your identity, the identity of a compound, is that it's made up of different types of atoms. And that's what makes a compound a compound. Now, to further elaborate this, let's look at your paper and let's be able to define your element and compound. So let's go to that paper and let's look at your question. Okay, so let me zoom that in and let's start with our definition for our elements. Okay, so let's start on this part here. An element is a blank substance. What category does it belong to in the chart? Who can remember? It is a type of blank substance. If you recall the chart, what was the main classification of matter where elements and compounds are there?
A chemical substance?
It wasn't chemical. Look at the chart.
Pure.
Pure. Very good. So it is a type of pure substance. Pure means it has a unique property that is not shared with any other types of elements. It is pure for itself, and it's not mixed up with anything else because it is on its own. It's made up of its own self. So an element is a pure substance that, because it is just made up of one type of atom, we cannot, so it shouldn't be, or it cannot be separated into simpler substances anymore. So cannot be separated because it is by itself made up on its own. So I hope you got the first bullet for the elements. Okay. Now, let me go for the second bullet onwards. Let me go to furthering our knowledge about elements. To make sure that we know the elements, we have to know where we get information about these elements. Are you familiar with this chart right here? Are you familiar with this? How do we call this?
Periodic table.
Periodic table of elements. So elements. So everything in this periodic chart are all the elements that make up everything on Earth. So matter is made up of anything that is shown in here. So right now, this is how our modern periodic table looks like. If you look at this section here, this is the very last element present. This is the 118th element, the very last for now. So there are 118 elements discovered. If you recall when you were in middle school or when you're in elementary, this section here was empty. Like there were boxes that were empty, if you can recall that. And there were also a moment in your middle school wherein the symbols here are 3-letter symbols like UUQ, UUN, it's a UUO. All those 3-letter symbols were here. But right now, if you look at the new updated periodic table, it has its own fixed name. And the symbols are already 2-letter symbols. It's updated. And it's all full up to the last box. So this is how our modern periodic table looks like. And as for you, I can't give you a printed copy of this, but you have your own copy, soft copy of this periodic table in your Teams. I have uploaded this periodic table chart in your Teams, and so you can always print it out if you have a printer and put it on your wall, because we're going to use this for a long period of time. And if you don't have a printer, don't worry. You can always save the soft copy and just open it the moment you need it. So just make your options as long as you know you have this in your Teams, okay? And so during exams, you don't have to memorize this. You can always refer to this during the exam. So just to let you know. So if you meet any of these elements in every box, it is automatically considered an element. And every element has a name, and every name has a symbol. That's the one in bold letters. The symbols can be 1 letter or 2 letters. If it's 2 letters, the first letter is capitalized and the second letter is always a small letter. When you write them down, you have to make sure that you are following the format of the periodic table. You don't follow your own way. Do not make your own font style. Always follow the capitalization for the first letter, and the second letter has to be a small letter all the time. That is how we are symbolizing our elements. So going back to your paper, number 2, second bullet. In the second bullet, it says each element has a unique name and a 1 or the other option is 2-letter symbol. A 2-letter symbol for these elements. Go ahead and fill out your own work, okay? Now, the third bullet is an information about the periodic table that I just showed you. So, the periodic table, because you see boxes and a very organized arrangement of your elements. So you have what we call the rows, the horizontal rows, and vertical columns. So how does it look like in here? The rows are the ones that has numbers 1, 2, until 7. And so you look at it from left to right, left to right, left to right. That's what we call horizontal rows. And we call those horizontal rows as periods. Okay? We call them periods. So that's a chemistry term, and that's why it's called periodic, because it has periods. And the periods will make us see a pattern, and we will further know that later on. So rows are called periods. And also we have vertical columns. How do we see that here? You see numbers on top, 1 all the way to 18. And that is all the way from top to bottom. Top to bottom. So those are what we call your vertical columns. How do we call these vertical columns? We call the vertical columns groups, or the other name is families. So if the elements belong to one column, that means they belong to the same family or the same group. And that is the term for the rows and columns in our periodic table. And last, for the elements part, which is the same with the first part, elements can it be separated or not? What did we say? Can or cannot? Cannot. So cannot be separated because it is on its own. Any questions so far on the part of the element? None?
No.
Okay. Let's go to the compound, okay? Compound. Let me just give an introduction about the compound. So let me show you this. Can you see what I have in here in the screen? What is it?
Salt.
Salt. This is an ordinary table salt. It's pure salt. Does not contain iodine. Doesn't contain iodine. So it's a pure substance salt. And you will see here the chemical formula of salt. Capital N, small a, so that means this is one atom, and capital C and small letter L. Small letter L is just a line, a vertical line. So if you have a big letter and a small letter, it's considered one type of atom. So Na is one atom, Cl is another atom. If you look at your periodic table, Na is called sodium and chlorine is Cl. So let me tell you a story first about this NaCl compound. Before NaCl is formed, Na was alone and chlorine was alone. It's just like all of you, right? You're not into a relationship. So I presume you don't have a love life or whatever because you're still very young. But me, I am already a compound because I'm married. NaCl is married, but before they got married, Na is alone and Cl is alone. So this is the story. Na is a very reactive metal. It reacts vigorously. So if you put it at room temperature, it's not going to stay still. It will react to anything that it surrounds with. That's how reactive this Na metal is. On the other hand, chlorine, as an element on its own, chlorine is very toxic. It is called a cleaning agent. Usually it is in bleach or disinfectants. It's in your Clorox. So this is highly toxic. You cannot take it in or else you're going to die. You're going to be poisoned if it's chlorine. But this is the wonder, this is the miracle of this. When sodium meets chlorine, they will form a chemical bond because automatically they have a chemistry. There are atoms in the periodic table that when they meet, automatically they're meant for each other. They have chemistry. And when they have chemistry, they bond And once a chemical bond forms, the initial properties of sodium and the initial properties of chlorine will no longer be there because they form one whole compound that is called salt, that's not reactive nor poisonous. But it is a salt that we can safely put in our food and that we can safely taste. And that's the beauty of a chemical compound. Because of the chemical bond that forms between atoms, you're forming another pure substance, and that has a different property from the previous elements. And that changes everything. In life, some people or majority of the people are meant to be with somebody, except for the peoples who are really for single blessedness. But majority of the people always have the natural tendency to find a partner that you can be with for a lifetime. And that changes everything, because the moment you get united with somebody and you commit yourself to that somebody, you become one. And you're no longer as you are, because you are united, you're bonded fully. That's just like the compound. Once it is bonded, it is completely a brand new substance. But young people out there, if you're looking at me right now, don't rush right now because you're still very young. Do not form a chemical bond yet. Form friendships instead. Do not rush things, you're still very young. It will happen at the right moment. Okay? So going back to my compound here in this chart. So a compound is made up of two or more elements that are chemically, what do you think should be the word here? Chemically, when they have chemistry, what is formed again? They form, how do we call the connection? The connection between those elements of different atoms? How do we call that?
Aligned?
In chemistry term, it starts with the letter B, and it looks like after a name of a famous person in the movie, James. You know James? James who? Bond. So in chemistry, when the two atoms like NaCl fall for each other because they have chemistry, they form a chemical. You just said it. A chemical bond.
I was doing something.
Okay, so they form a chemical bond. I only have one student here paying attention. Half the others are paying attention. So here, what should be the missing word? Elements that are chemically, how should we term it? Chemically? Should we just put the word bond? Chemically? Chemically? Bonded. So in other words, there should be a chemical bond that exists between these atoms so that a compound is formed. Second bullet. What was the chemical formula of table salt again? The one I showed you. Who can remember? How do we write the chemical formula?
Capital N, lowercase a.
Capital N, lowercase a. After that?
Capital C.
Capital C.
Lowercase l.
And lowercase l. So that is the chemical formula of your table salt. And similarly, H2O is the chemical formula of water, and they're all considered to be compounds because they're made up of two or more elements. Let's go to the third bullet. Compounds can be broken into components by physical or chemical means. Can we divorce compounds? Can we split them up? Is it possible? Can we split a compound? Granting, yes, you can. Just like marriage, there's always a divorce. But same as divorce, an analogy, divorce is painful, costly, And it's going to take a long process, right? It's a long process. Same thing with compounds. You can split them up. You can destroy the bond, but it's not ordinary. It's not an easy method. So compounds can be broken into components by a complicated method which we call a chemical method. So a complicated method of breaking chemical bonds in compounds is what we term chemical means. When we say chemical means, your substance has to undergo chemical reaction for the bonds to break. Okay? So that's a complicated means. On the other hand, if we proceed to number 1 in here, it says compounds cannot be broken down easily. So the easy method is what we call physical methods. So compounds cannot be broken down by ordinary physical methods. So when we say ordinary methods, like I heat it or I put some filter, those are ordinary physical methods, and compounds do not break that way. So that's why cannot be broken down by physical methods. And so therefore, what do you need? You will need a, what is it? What type of change will you need to break down a compound? What are the 2 types of changes? You will need a chemical change to be able to break down a compound. It should be a chemical change. And number 3 is a recall of what chemical change is all about. It's a change that produces matter with a different, same like NaCl, when they form NaCl, the properties change. So every time there is a chemical change, the properties will change because you're forming a different substance. And inside the parenthesis it says 1 or more substances changing into always brand new substances. Always new substances that no longer is the same with your starting substances. Just like sodium chloride, it's not poisonous, it's not reactive, it's salt. And salt is new. Okay? And lastly, the properties of compounds are usually blank from those of their compound elements. So they're always or usually different from those of their compound elements. And that's what makes compounds compounds. Any questions so far with the element and compounds? Before we proceed to the 4-item quiz on this paper. Do we have any questions with all of these? None so far? Period 6?
No.
Okay. Let's go to the quiz, okay? All together. You have to answer this all together with me. The quiz is a practice. It's a practice of identifying if the examples there is an element or a compound, okay? Before we answer, let me tell you about every item in here, okay? So number 1, sucrose, or commonly known as our sugar, table sugar. Sucrose or table sugar has a chemical formula of C12H22O11. Never mind the numbers. The numbers will just represent how many of that atoms there are. But I want you to look at the composition of table sugar. It has capital letter C, capital letter H, and capital letter O. If you have capital letters, and I told you about the periodic table, does sugar have only one element, or does it have more than one element? Answer, please.
More than one.
More than one element. Specifically, how many elements?
3.
There are
3.
3. So
Oh,
C,
oh,
yeah, so there's C, that's carbon. It's capital letter C, so that's one element. Another capital letter H, so this is hydrogen. And another capital letter O, that's oxygen. So all capital letters are different elements. And because sucrose contains these 3 elements, therefore what is it? An element or a compound? What is it? It is a?
Is it compound?
It is a compound. Be sure with your answer. So a compound always contains more than one type of element. More than one type. So obviously you have C, H, and O. There are 3 elements in there. Automatically it is considered a compound. Any questions about sucrose or table sugar? Questions? Okay, let's go to number 2. Number 2 is helium in a balloon. Helium. Who can tell me what is helium? Is it an element or a compound?
An element.
An element. Very good. How do you confirm that? Periodic table of elements. Helium is here. It is element number 2. It's the lightest, second to the lightest element after hydrogen. Hydrogen is here. After hydrogen, it is helium right here. It's alone and helium alone. So therefore, helium is considered an element. Question: why do you think it wasn't hydrogen that's put in a balloon? Because hydrogen is lighter than helium. But why is it? Why do you think we're not using hydrogen as something that we inflate our balloons with? Why do you think? Who has an idea? Who has an idea? It's because hydrogen is
No.
flammable. Very good. Hydrogen is flammable. Hydrogen, if you use hydrogen in a balloon, put it there and somebody smokes, or there's a campfire or something that's hot, it's going to pick it up and it's going to explode. So hydrogen is flammable. It's not safe. So the very safest gas that we can use for balloons that's light and can fly right away is the second element, helium. So that's why we're using helium, not hydrogen. Okay, number 3, baking soda. Let me show you a real baking soda here. And it has the chemical formula NaHCO3. Look at the capitalization of the letters and tell me if it's an element or a compound. Who can tell me? It is a compound or element. It has Na, it has H, it has C, it has O. So what is it? If it contains 2 or more elements.
Oh, compound.
2 or more elements, it is considered a compound. So baking soda is a compound. It has sodium, it has hydrogen, it has carbon, and it has oxygen. It has 4 elements in there. So that should be considered a compound. So that's baking soda. Number 3, diamond. A pure diamond contains what element? Who can share his or her knowledge about diamonds? Diamonds are made up of what element?
Carbon.
It is carbon. Very good. And what is carbon? Is it element or a compound? Let me show you the periodic table. Look at carbon. Look at number 6. Do you see number 6 right there? It's carbon. So it's considered one type of element. So diamond, a pure diamond, is classified as an element because it's made up of, let me put that, it's just made up of carbon. Any questions so far with differentiating an element in a compound? Questions?
No.
Okay.